Good. So good afternoon, everyone, and thank you for having me again this year to present the status and trends of PV technology. It's just in Canada, but I might be dealing with international trends as well. So a lot of what we are hearing in this conference deals with the physical phenomenon happening at the nanoscale. So for the next half hour, I will invite you to take a step back, several orders of magnitude, so that we don't look at the nano, but more at the macro scale of the PV. So the way the presentation is divided is that I will first describe trends related to the PV market and the PV technology. And then I will cover the deployment framework, the current deployment framework, and what we can expect from over the coming years, the different policy, how those policies are going to affect the deployment of PV systems. And then during the last year, the International Energy Agency published a new PV technology roadmap. And I think that's a very interesting report, and I would like to bring maybe some of the highlights of this report to your attention. So let's start. Let's start with cumulative installed PV capacity. So at the international level, the IEA PVPS has released its preliminary numbers, and it seems that in 2014 there were about 38.7 gigawatts of PV that was installed in the world, mainly in China, in Japan, and in the US. So that brought the cumulative installed PV power capacity at 177 gigawatts. So it was a good year, about the similar level as what we experienced last year, which was about 40 gigawatts as well. Now, with the increase of PV capacity, so does the increase of electricity production in the global energy mix. So this year, one of the big milestones I'm proud to state is that now PV represents 1% of the world electricity generation all over the world. And if we look more closely at the national PV electricity mix for certain countries, it can reach up to 8%. In Italy and above 7% in Germany and Greece. So definitely PV is starting to make a more and more important contribution to national electricity mixes. In fact, PV now accounts for 1% of the electricity production in 19 countries and one province, the province of Ontario. Yes. So Canada, we're still at about 0.4% because there's not as much PV deployment in other provinces, and we're a country that uses a lot of electricity and produces a lot of electricity, but nevertheless it's growing. So if we zoom in now on Canada, last year was a very good year. There were 627 megawatts installed. That was a 52% increase over the previous year, which brought the total capacity to 1.8 gigawatts. Mainly in the centralized application versus the distributed, which is more like the solar homes or large building systems, 100 kilowatts or so. So this is about the sixth year in a row, 6 or 7 years in a row, that we see a growth rate above 50% from year to year. Now we have to keep in mind that most of this growth, that was the total growth in Canada. Well, the total capacity in Canada is 1.8 gigawatt, and 99% of that capacity is installed in Ontario, with a total capacity of 1,823 megawatts. So there's more than 21,000 solar PV systems that's connected to the grid in Ontario. And this number is set to grow even more, as there is another 949 megawatt of contracted capacity set to be installed in Ontario through the feed-in tariff, the microfit, and the resub program. Although the resub capacity now is fully installed, so we need the fit and the microfit program, and that 949 megawatts will be installed in the coming years. What's also interesting to note is that the PV capacity is also growing in other provinces like BC, Saskatchewan, and Alberta, and also in the Northwest Territories that has a program to install 1.8 megawatt between now and 2017. So, and the capacity is growing even though there's very little or no incentive at all. So it's growing because there's consumer interest. It's growing because we're about reaching that point called grid parity, where at the retail level, where the price of installing a PV system on one house is over a period of let's say 25 to 30 years, is the same price as paying your utility bill over that period of time. So we're seeing quite very good growth in these other markets here. You can see Alberta, the growth rate above 10% for the last couple of years. Now, if we jump now to a different aspect, PV technology, market trends in PV technology. On the left, we have a graph showing the manufacturing capability of different countries over the last 5 years. And what we see is that although China was pretty much producing the same amount of capacity as market leaders like the USA, Germany, and Japan in 2009, in the last 4 or 5 years, its manufacturing capability has increased tremendously, and it now dwarfs the production capability in these other countries. So China is the world-leading producer of PV cells and modules. It produced 58% of the cells in 2013 and 65% of the modules in the same year. Now, if we look at the graph on the right, this shows that between 2006 and 2009, the thin film technologies were gaining market share. So we could see that the market share of crystalline silicon technologies went from 91% of the market down to 70% of the market. However, starting in 2010, China's additions of capability was mainly in the crystalline silicon area. So that brought back the manufacturing market share of crystalline silicon back to 90% nowadays. Nevertheless, the thin film technologies are making great leaps forward. When we look at the large thin film manufacturers, First Solar, that manufactures cadmium telluride modules, produced 1.63 gigawatt in 2013. And also Solar Frontier from Japan produced almost 1 gigawatt of CIGS modules in 2013. It's also noteworthy to report that a number of countries are also involved in CPV cell production, although at a much lower scale. Now, the price of the module, the retail price, that's the price that you would pay if you went to a distributor, a retailer today and say, I want to buy a PV module. Well, that price has decreased by 11% in 2014. It moved from 95 cents to 85 cents per watt. And if we look at the evolution for the last 10 years, that module price has been decreased by a factor of 6 since 2014. So previously, module prices used to represent about half the cost of the system. And nowadays, that cost is about a quarter or even less of the price of an installed system. So last year, the average price of a grid-connected PV system ranged between $2, that's for a large megawatt-size PV scale system, to about $2.77 for a large commercial system, let's say 100 kilowatts and above. And then when you are the residential size, lower than 10 kilowatts, the price was between $3 and $4 per watt, depending on where you are. In Ontario, it's closer to 3 because there's a big volume of installation. Maybe in Quebec, where there's less installation, it's closer to the $3.50 mark. And up north, it's twice that price. It's closer to $7 or $8 per watt. So, now in terms of deployment, how does that affect deployment? If the price of PV modules is decreasing, there's 21,000 households in Ontario that has PV modules on their houses. So these people, there's a new term that has been coined. So these people, they both are consumers of electricity and producers of electricity during daytime. So when you contract both, you get the new term that has been coined. They're called the prosumer. And now there's a growing body of policymakers and utilities and many stakeholders are wondering are we going to us now that PV is almost or has achieved grid parity in a number of markets? Are we about to see people turning their backs on the utilities and saying we're not buying our electricity from you anymore, and so that could affect utility revenues? So there was a study published by the IEA RATB last year that is stating that no, there won't be a prosumer revolution yet. And there was in a presentation yesterday, someone was saying, we've reached grid parity, why didn't we have a parade and celebrate it, and why don't we see PV everywhere? Well, there's a good reason for this. It's because we need the grid. We could, yes, we've reached good prices for PV electricity, but if we don't have a grid to export our production, our excess production during the day, and if the payback scheme, the net metering scheme is not good enough, then the PV system won't be economically attractive option. So, for example, in Colombia, there's high retail rates, so PV would make sense, but unfortunately, the PV cannot feed in. They allow on-site CHP with palm oil, but PV is not allowed to feed into the grid. So we don't have access to the grid, we cannot sell the excess electricity, so that kills the market. In Spain has had a lot of success in the mid-2000s, maybe too much success, so at some point the government introduced a fixed charge, which then made PV less attractive economically, and there again, the market has slowed tremendously. However, in areas where there's the different net metering policies and the support schemes are implemented, like in the US, for example, where the interconnection process is streamlined and where there is net metering and the residential rates are more volumetric than fixed, then we can see a market that's adopting PV more and more. Same thing in Germany. If you have, again, a well-aligned, streamlined interconnection process and some feed-in tariffs that buys back the excess electricity, then you can see the market expanding. So, in other words, the policymakers and the utilities still have tools to accelerate or to slow down the growth of deployment of PV systems. So, in order to transition to a more favorable scheme for PV, there's a number of approaches that can be used to tweak the current system. You can use, well, as we see in Ontario, do some feed-in tariffs or net metering, or in other states you can have tax incentives or rebates for solar systems. So all of these approaches will favor the prosumer market. Also, but more, I think, fundamentally, at some point we'll have to address the very structure of the business model of the utilities if we are to grow even more. For example, ENMAX, that's a utility local distributing company in Edmonton, in Alberta, they offer to install PV systems on the roof of their customers. So it's a utility that provides financing or options to customers who want to generate solar electricity. And so this way utilities become neutral managers of grid infrastructure, or they finance consumer infrastructure. So they, instead of resisting this change, they actually take part in the transition. Over the long term, that can be an interesting, viable solution. Also, closer to here, PowerStream, a local distributing company in the area of Toronto, is integrating some smart grid infrastructure in its operation. And that allows to be more interactive with the customers, to be price responsive. So there again, by changing these business models, that's a way to move forward. On the other hand, the utilities also have the power to constrain prosumers, and that already exists. For example, in Quebec, if you are a nice building integrated PV system that's about 50 kilowatts, well, you have to sell all your excess production for free. You're giving it to the utility. They're not buying it back. And here's some utilities. You cannot interconnect necessarily. Maybe there won't be space for your system to interconnect in weak feeders, or if you go beyond the 7% level of load, then they won't let you interconnect to the grid. So there's restrictions that can be put in place, adding taxes, adding standby charges for on-site generation. So all this will slow down the deployment of systems. On the other hand, that's a strategy that could fire back, because that works because the price of storage is still high. So nobody can say overnight, okay, I'm installing PV in a battery and forget about the utility. They need the grid to sell back the electricity. But in a number of years from now, when the price of storage is going up and you have energy efficiency and cheap PV, then they could say, I'm installing a battery, a PV system, and the utility, I'm not hearing about them anymore. So then in a context like this, it would lead to a more disruptive transition towards the prosumer. So there's, I think it will be profitable for everyone, to all stakeholders, the solar industry, the utilities, the policymakers, to sit together and to really divide a system whereby some part of the charges are now fixed so that the utility gets somehow compensated for the loss of revenues, but on the other hand, the prosumers are not penalized, because in the end, PV technology is environmentally friendly, it brings social economic benefits, so it's something that we want to encourage as a society. So there's a graph there in the study that shows that by 2030 or 2050, the storage, grid defection of the storage might become a reality if there is no effort from the different parties. And also by that time, there may also be wholesale competition at the wholesale level. So you could install some some operator might want to install a large PV farms, and then they could compete with conventional generation. But if only for now, it could be at the 2030, 2050 horizon. So, with this in mind, the IEA developed a new version of its technology roadmap. You may remember that in 2010, the International Energy Agency came up with the PV technology roadmap. However, 4 years later, we had already accomplished the installed capacity objectives for 2020, and we had already reached the cost reduction objectives for 2020. So they said, okay, well, maybe it's time to update it and set some more higher goals for PV because they're too good. So that's what they did last year. They published a new edition where they set development goals in different areas. We've seen that policy and financing is one important area, but they also set policy for grid integration of PV systems and also for solar cells and PV modules. So just briefly, I thought it would be interesting to bring this to your attention. In case who knows, maybe it might inspire some of you working in this area. So regarding PV system integration, and there's many ways that the PV system could help the grid, and actually we should try to find ways to integrate PV system better. Amongst those, there's the development of more accurate PV forecasts to facilitate the management of the electricity production and transition on the grid. Also, if inverters could be allowed to help the grid, to support it, to provide voltage support or frequency support. When there is a problem in the grid, it could stabilize the grid instead of just disconnecting, like it's required to do right now. That could lead to an improvement or a benefit to the utilities. In addition to this, well, there's a number of things that can be done. We don't want to interconnect all PV systems in a hub where they would lead to overproduction, especially if there's not too much load on that feeder line, right? We want to balance demand and production. Also, looking at the load management and adding flexibility and adding storage capability. Actually, the advent of the electric car might represent an interesting opportunity to be able to manage the variability of solar PV. So these are all, I think, worthwhile goals to work towards. And then there's the time frame that's recommended to go towards this. Now, if we go at solar cells and modules, yes, the price of systems, the price of modules, I should say, and the price of cells has decreased tremendously in the last couple of years. I showed that earlier. We have to take into account that all the gains that were made because of China's large manufacturing installations, all the gains that we made in manufacturing, a lot of that potential is already tapped. But we need additional cost reduction if we are to reach parity at the wholesale level, that is competing with the traditional generation need. So in order to reach those cost reductions, we need further advances in research. We need advances that will lower the cost per kilowatt hour of solar electricity, and there's different ways to get to this. As usual, you can keep the cost pretty much constant, but improve the efficiency of the different technologies. So there are some goals there that will certainly be completed by 2017. At least we can strive for that. Also, we can try to get more electricity out of our PV system, that is, increase the PV performance ratio and decrease the degradation rate. And also work with larger wafers and decrease the use of the silicon and silicon technology. So all this would help to bring the cost down. On the other hand, in parallel to this, I should say, we can also aim to develop new products, especially building integrated products. The IEA foresees that about half of the deployment will be in large area systems, but the other half will be in distributed systems, households, buildings. So it's important to develop products to seize opportunities in that market. We may also wish to develop certain modules that are specifically designed, let's say, to perform well in the north, or perform well in temperate climate, or perform well under desertic climate. So there again, maybe there's opportunities to get cost reduction by doing it. So, in short, I wanted to end with a comparison of where we were when this network started 5 years ago. In the world, the market was about 7 gigawatts, and nowadays it's closer to 40 gigawatts. So it was multiplied by about a factor of 6. The electricity generated by PV was negligible, but now it's 1% of the global energy mix. And in Canada, the market exploded from 54 megawatt to 627 megawatt per year, and the capacity was multiplied by 30. So that's quite an achievement in only 5 years. Now, however, when we look at this is also small compared to what we need to do. The IEA did a study, and if we are to keep global warming within 2 degrees between now and 2050, PV has to play a much larger role. In fact, it has to be 16% of the global electricity mix by 2050. And that implies an annual market of 200 gigawatts. So about 5 times what we have now today. So there's more potential that lies ahead, but also there's a lot of space for a lot of these innovative concepts that you guys are coming with, and that will need to be implemented in order to reach that scenario. Thank you for your attention.
Thank you, Yves, for the always very interesting summary. We have time for questions. Okay, I'll take the chair's prerogative to ask a first question. You discussed some of the regulatory barriers to interconnection and the like that we have in Canada. Is there anywhere in Canada that you think is doing this right, either provincially or for the interconnection, or utilities that are embracing this that could be a model?
I think there's a consensus right now that there's no universal recipe that everyone can adopt. There's no consensus right now as to the best approach regarding this. There's only the way they divided this is there's factors that will lead to more prosumer-friendly markets and factors that will lead to slowing down the prosumer market. I think depending on the different realities, in some cases you might want to stimulate it more. On the other hand, if your network is not ready to get that capacity in, or it needs reinforcements, maybe other solutions will come into place. So unfortunately, I don't have a clear and precise answer to give you.
Very politic.
My question is concerning the second road of 2014. Is this an estimate based on the installed or is real produced?
It's actually an estimate based on the install capacity. So the install capacity is the number that was counted, that was accounted for, and then based on this, they assume a global performance yield equivalent to such that leads to that electricity production. Yeah.
Are there somewhere in the world real number, or everything is estimated?
I wish there was the real numbers, but in fact, no, not all the electricity is not accounted for where we don't have the means to do this. So the best that we can find is really an estimate based on the install capacity and the global average yield for the system, which could be reasonable. Yes.
My question is still regarding more or less this, when you mentioned that we should aim at 200 gigawatts per year in order to get rid of the global warming, how important is it that those 200 gigawatts are implemented in industrialized areas of the world, as opposed to those areas where there is no grid connection at all?
Your question is regarding that this number 200 kilowatts?
Well, the 200 gigawatts, should we look at implementation in the industrialized spaces where we're actually producing the CO2, we are producing the pollution, rather than what if those 200 gigawatts come from countries with no grid?
Yeah, that's a good point. And I think you'll find the exact answer in the IEA PV roadmap. There they study both the potential for PV deployment, because you need the resource, you need interesting resource, and they look also at the actual, is it feasible or not given the infrastructure, and they look also at the energy mix, right? If you install 10 megawatts in Quebec, where basically 99% of the electricity is produced by hydroelectricity, you get a much different impact than if you install that same capacity in Alberta, where it's mainly coal and natural gas. And I believe those factors were factored into the IEA roadmap.
Regarding, you saw that IEA reported that by 2030, I believe 50% will be on farms, PV farms, and the other 50% will be on buildings. From that 50% on the buildings, what do you think is the percentage of the pie that will be on the AUV?
This, I don't think they go into this level of detail. And because obviously we need to take into consideration or make assumptions about what's the price difference between BIPV and building supply PV, BIPV, and the availability of products. Now, my opinion is that as time goes on, we'll be going more and more towards BIPV products for buildings, because a building is not a power station, right? You don't want necessarily to produce electricity at a lower price. You want to preserve aesthetics and have additional value. PV might be a green value for the headquarters like IKEA that has implemented PV. So with this in mind, I think that we'll go more and more towards BIPV developed products, and with the volume, the price of these products will decrease. So while I don't have the numbers, I think that the general trend will be to go towards more BIPV.
Great. So we have time for one more question.
There's no estimate for Canada for 2030 and 2050. Is it missing? Or could you provide an unofficial guess?
I guess I was lacking inspiration when I put those numbers. Those are the numbers on top provided from rigorous analysis from the IEA, but there was no analysis made for Canada specifically. And the installation, the market is so complex, who knows what's going to happen in 5 years from now. Just in Ontario, we're planning to transition to a net metering program, but then maybe, who knows, maybe Alberta will have a program now that the NDP is in power, or you know. So it's very tough to project this. But I'll make one projection. See, in 2009, there was only one province that reached the 1 megawatt mark. In 2014, there is 4, and by 2030, there will be 10 provinces and territories that will have surpassed the 1 megawatt mark.
If
If it's an intent.
Okay, so let's thank you one more time.